Hello everyone, my name is Alexei, and today I am going to demonstrate and explain to you in simple and clear terms exactly how a two-stage cargo cooling system operates, focusing specifically on the details shown in this diagram. After we finish that, we will then move on to the Cascade system and carefully analyze the Mollier diagram for both the two-stage system and the Cascade. The fundamental key idea that we need to understand here is that this is the same direct cycle. Compression takes place in two stages. This is done because with a large pressure difference, a single compressor operates inefficiently and overheats. For this reason, the load is shared out between two stages. We start with the tank. Liquefied gas is stored inside the storage tank, but due to heat influx, vapor begins to form. Boil-off gas. This vapor then exits the storage tank and enters the liquid separator unit. Within the liquid separator, any remaining liquid droplets are carefully removed so that only completely dry vapor enters the compressor. This process is critically important for the long-term health of our equipment. Next, the vapor enters the first stage of the compressor, where the initial compression process takes place. The pressure rises steadily, the temperature rises as well, then increases even further, and we get a very hot superheated gas. However, it is still not quite sufficient for the condensation process to begin. After this step, we direct our compressed gas into the intercooler, which serves as an intermediate cooling stage. And here is a very important point to understand about the intercooler's function. As the gas cools down significantly, it undergoes a process where it partially condenses due to the substantial drop in temperature, which naturally causes the total gas volume to decrease. At the same time, this thermal change ensures that the overall operating efficiency of our compressor unit, as well as the performance of the entire system as a whole, increases quite remarkably. If there were no intercooler, which is absolutely crucial and essential for us, if it were not present in the system, and we were to directly transfer our vapor from the first stage to the second stage, then our compressor would operate under much more difficult conditions. Now moving on, the cooled gas enters the second stage of the compressor. Here the second compression takes place. The pressure gradually increases to the specific threshold necessary for condensation in seawater. After the second stage, we again have superheated gas, but here, this is very important, high pressure. This process actually works to our advantage because it will be channeled directly into the condenser, where it is gradually cooled down by the surrounding seawater. And so condensation takes place in the condenser. The gas turns into liquid at an almost constant pressure. Next, the liquid enters the collecting vessel, where the flow is carefully accumulated and thoroughly stabilized to ensure consistent quality control throughout the process. Here is a very important point that some people often simply overlook. A significant part of this liquid that we have obtained is used specifically to cool the intercooler. In other words, the entire system partially cools itself down. This process effectively increases overall efficiency and significantly reduces the total thermal load. Following this stage, our main liquid flow passes through the expansion valve. At this point, throttling occurs. The pressure drops quite sharply, the temperature decreases significantly, and a cold mixture is formed. A specific mixture of liquid. This is what we call condensate. This cold mixture is carefully directed back into the tank. And thus, the entire cycle is finally complete. I hope everything is clear here. Now let's move on to the next one. Here we have a Mollier diagram, as you can see. So look, we start from number 1. Suction from the tank from number 1 to number 2. This is the suction stage, 2 and 3. This is the first stage of compression. Pressure and temperature continue to rise, but not quite at their peak yet. As you can see, that's why we shift our position slightly to the side, right? we do not simply go straight up on the diagram because in this specific section of the cycle, both the temperature and the pressure are increasing simultaneously. Then, as we move from stage 3 to stage 4, we pass the working fluid through the intercooler to reduce its temperature. This is the intermediate cooling. The temperature drops while the pressure remains the same. Remember, this is what we talked about. It reduces the load on our compressor on the second stage. That's it. From point 4 to point 5 is the second stage of compression. In this phase, the pressure increases once again, rising to the level we need, to the final target level, and then from point 5 to point 6, condensation takes place as it is cooled with seawater during the transition from point 6 to point 7. Here we have a liquid cooling system partially running through the intercooler. As you can observe, the section from 7 to 8 is where the expansion valve is. There is a sharp drop in pressure. Well, from 8 to 1 is the return of the liquid to its initial state and evaporation in the tank. I hope everything is clear here. Alright, let's move on. Now, the Cascade. The cargo cooling system on LPG carriers operates in this way, utilizing a Cascade refrigeration system. So how does it work? And what exactly is it that you are seeing here right now? What is depicted here? It's important to immediately grasp the key idea here. Unlike a conventional system, we have two independent circuits, all that function together in sync. The first is the cargo circuit, the second is the refrigerant circuit. The first system is responsible for cooling the cargo, while the second one is used to cool the primary circuit. The first point is the cargo tank. Inside the cargo tank, we have the cargo itself, which gradually begins to heat up on its own, and evaporation occurs, and vapor is formed. This vapor exits the tank and is directed to the liquid separator. Here, just like before, any possible liquid droplets are separated so that only dry vapor goes to the compressor. Next, this boiled off gas enters the specialized cargo vapor compressor unit. Here, it is compressed and its pressure and temperature are significantly increased. And at the output, we get this is superheated gas. After the compressor, the flow is then carefully directed to the cargo condenser. And this is where the primary and most significant difference of the Cascade system begins. In the cargo condenser, our vapor is not being cooled by the surrounding seawater as it was in the conventional system. It is cooled by means of another circuit, the refrigerant circuit. To put it another way, inside this heat exchanger, one of the fluid flows is our cargo. Here we can see it. It's red, then turns blue and returns to the tank. This is the first circuit, and the second circuit is the yellow one, see? That's the refrigerant, cold refrigerant. As a result, condensation occurs in the cargo condenser. The cargo vapor turns back into liquid. After that, the liquid refrigerant flows through the expansion valve. The process of throttling then begins to occur. Consequently, the pressure drops, the temperature decreases, and the now cold liquid returns back to the storage tank by traveling through the condensate line. We are cooling the cargo, lowering its temperature by removing vapor. These are vapors. And the more quickly we do this, the faster we can cool them all down. Let's take a look at the second circuit, which is the yellow one. This is the primary refrigerant circuit. It is this specific circuit that provides the essential cooling for our entire system. The refrigerant itself, located within the cargo condenser at point number 4, after it has absorbed heat from the cargo condenser, evaporates and gradually turns into a gaseous vapor. This vapor then enters the refrigerant liquid separator, where any remaining droplets of liquid are effectively separated out. Next, it moves into the refrigerant compressor. Inside the compressor, the refrigerant is compressed, causing both the pressure and the temperature to rise once again. After that, the hot gas is directed into the refrigerant condenser, which is cooled by the circulating seawater. At this stage, the refrigerant undergoes a process of condensation. It reverts back into its liquid state once again. Our liquid refrigerant then enters the collecting vessel, where it gradually accumulates and is subsequently directed toward the expansion valve. Here, as always, the pressure drops quite sharply, the temperature decreases significantly, and a cold two-phase flow is finally produced. This extremely cold liquid refrigerant is then sent back to the cargo condenser, where it efficiently absorbs the excessive thermal heat energy from our cargo, and the entire refrigeration cycle continuously repeats itself over and over again. To put it simply, one cycle cools the cargo, and the second cycle cools the first. That is exactly why the system is called a specialized Cascade refrigeration system. The main advantage of using this system, is that it allows for attaining much lower temperatures and operates with a higher degree of efficiency, especially when the temperature of the seawater is high. Well, I hope that's clear. Let's move on. In this view, we have a Mollier diagram for the first cycle and also for the second cycle. The first one represents our cargo and our refrigerant. As per the usual procedure, we begin at the first point, which is the suction phase. Suction occurs from the first point to the second point. As we previously discussed in our earlier session, the gas coming from the tank is currently at a significantly lower pressure and a reduced temperature level. Moving from the second to the third point, we gradually reach the specific required levels of temperature and pressure. And after that, the process of condensation begins to occur from point 3 to point 4. But here, the condensation of the cargo takes place within the cargo condenser, not by using seawater, but instead by utilizing our specific refrigerant. As we've already discussed, from point 4 to point 5 is throttling. This is our expansion phase. The shaft works here, then from 5 to 1, the evaporation process takes place within the tank. Now, let's move on to our refrigerant. The principle is exactly the same. So here we have the process going from 10 to 6, which is evaporation, and then from 6 to 7. This is the suction and superheating stage. The gas goes into the compressor from 7 to 8. This is compression, an increase in pressure and temperature. From point 8 to point 9, the process involves condensation, but in this specific setup, it is achieved using seawater for cooling purposes. Following this, the gas travels from 9 to 10, which represents the throttling stage. At this point, the substance has transitioned into a liquid form and passes directly through the expansion valve. This results in a significant drop in pressure and further cooling, and finally, a resulting mixture returns safely back to the cargo tank for storage. That's all for today. Thank you very much for your kind attention. I really hope this video was informative and helpful to you. I sincerely did my very best to provide this content. I did my best. Thank you so much. See you soon.